In this video, we'll talk about infinite series. So, an infinite series, it's of the form sum as k goes from 1 to infinity of a sub k. So basically, if we write a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n plus a sub n plus 1 and so on, this is an infinite series. Now, if we add s sub 1 is the sum of the first term. S sub 2 is the sum of the first two terms. S sub 3 is the sum of the first three terms. And so on. S sub n is going to be the sum of the first n terms. So it goes all the way up to here. Now these S sub 1, S sub 2, S sub 3 and so on are called partial sums. So if a sequence of partial sums converges, that is, if the limit as n is approaching infinity of sum as n, k goes from 1 to infinity of a sub k equals limit as n is approaching infinity of s sub n equals L, then the value of the infinite series is also L. If the sequence of the partial sums diverges, then the infinite series also diverge. So in conclusion, find s sub n and then find its limit. So a few important or popular series, geometric series, which have this format a plus a sub a times r plus a times r squared plus dot dot dot, where r is the ratio, has the sum, if you remember, the first term times the ratio to the number of terms minus 1 over r minus 1, and here is the proof of that formula, which I find interesting, so look over it. So now the sum of the n terms of a geometric series, which is going to look like this, or sometimes it's a times r to the n minus 1 over r minus 1, they're the same thing. What happens to this is this sum diverges if r is greater than or equal to 1. It's equal to, well, to something if r is between negative 1 and 1. Well, if r is between negative 1 and 1, it's going to be equal to, well, this quantity is going to go to 0. So it's going to be a over 1 minus r. So it's all a typo there. And then for r less than or equal to negative 1, it diverges. So it's a over here for r being negative 1 and 1. So 0.2 to the k and 2 to the k. Now, because we have the summation, we are talking about series. When we had just 0.2 to the k, when k was going to from 0 to infinity, it was a sequence. So please keep in mind, if it's 0.2 to the k, when k is from 0 to infinity, we have 1, 0.2, 0.2 to the second, 0.2 to the third. This is called sequence. And we know that it converges to 0 if we plot the points. Now, if we do 1 plus 0.2 plus 0.2 squared plus 0.2 to the third plus and so on, this is a series. So in order to check if the series converges, we actually calculate the sum of the first n terms, which this one is a geometric series, so it's the first term times the common ratio, which is 0.2, right? To get to the next term, we always multiply by 0.2. So it's to the n minus 1 over 0.2 minus 1. So this one, as n is approaching infinity, this one is approaching 0. So we end up with negative 1 over negative 0.8, which is 1 over 0.8, or 10 over 8, or 5 over 4, which we had here as well. Okay, so let's take a look at a few series and how we find if they are convergent or divergent. So this series, which is called telescopic series, and they are pretty popular and show up in many problems, are series that when we expand them, so when we start giving to k the value of 1, we get this. When we give the k the value of 2, we get this difference. If we give the k the value of n, we get this difference. So now just notice how this term cancels with this one, this cancels with the next one, this cancels with the previous one, so you are left with this 1 over 3 minus 1 over 3 to n plus 1, which when we calculate the limit as n is approaching infinity of this, we end up only with 1/3, as this one is going to approach 0 when n is approaching infinity. So basically, this sequence, this series, it's convergent, and its actual value is 1/3. Let's take a look at another problem. It says evaluate the series and find S sub n. So when we take a look at this one, if I was to give values 1, I would get 1 over 2, plus if I give the value 2, I get 1 over 6, plus if I give value of 3, I get 1 over 12, and so on. So is it gonna help me? I don't think it's gonna help me too much. So what I'm gonna do is I'm gonna take this term 1 over n squared plus n, and I'm gonna write it 1 over n times n plus 1. And then we are gonna use partial fractions, which we learned in this course, to actually break it down into an a over n plus b over n plus 1. And if we multiply by n times n plus 1, we actually obtain, let me just write that, this piece, right? We get 1 equals a times n plus 1 plus b times n. So if n equals negative 1, we get 1 equals negative b, or b equals negative 1. And if n equals 0, we get 1 equals a. So in other words, this sum here, which I don't need these terms because they didn't help me much, this sum here can be written sum, as n goes from 1 to infinity, of 1 over n minus 1 over n plus 1. So what happened? We actually made this series to look like a telescopic series. So S sub n is going to be equal to sum, as k goes from 1 to n, of 1 over k minus 1 over k plus 1. So if we give to k the value of 1, we get 1 over 1 minus 1 over 2, plus, right, this means plus. If we give k value of 2, we get 1 over 2 minus 1 over 3, plus. If we give k value of 3, we get 1 over 3 minus 1 over 4, and so on, plus. And I'm going to write the previous term, which is going to be 1 over n minus 1 minus 1 over n, and then plus 1 over n minus 1 over n plus 1. So I try the n minus 1 term, and then I put the n term as well. Why? Because now we notice how easily these terms cancel. This one cancels with the previous one, and this one with this one. So we actually end up with 1 minus 1 over n plus 1. We found the S sub n. S sub n, it's this. So limit, as n is approaching infinity, of S sub n, it's actually equal to 1. So we found out that the series sum, as n goes from 1 to infinity, of 1 over n squared plus n is equal to 1. Let's take a look at the next problem. It says evaluate the following geometric sum. So we have sum, as k goes from 0 to infinity, of 3 to the k. So if k equals 0, we get 1, plus 3 to the first, 3 to the second, 3 to the third, dot, 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 3 to the 8th. We know it's geometric because to get to the next term, we always multiply the same factor of 3. It's the same value. Now, S sub n for a geometric, it's the first term times 1 minus the common ratio to the n over 1 minus r. I usually use this a sub n equals r to the n minus 1 over r minus 1. It's the same thing. So in our case, the first term is 1. Then 1 minus 3 is the common ratio to n, the number of terms. So again, we go to the 8. So from 1, 2, 3, we have 8, up to 8, we have 8 terms. Plus this one, we have 9 terms. Over 1 minus 3. So actually, you can do the math, or 3 to the 9 minus 1 over 3 minus 1. So you can put that in the calculator and find 9,841. That's what I got. Let's see another problem. Evaluate the following geometric sum. Okay, so it doesn't really look like a geometric one, right? So what I'm going to do, I'm going to factor out 1 over 4 to see what happens. So I get 1 plus 1/3 plus 1/9 plus 1 over 27 plus dot 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 plus 1 over, well, this is 7 to 9. So basically this can be written 1 over 4 times 1 plus 1 over 3 plus 1 over 3 to the second plus 1 over 3 to the third plus 1 over 3 to the fourth is 81, and then 1 over 3 to the fifth, which is 243, and then plus 1 over 3 to the sixth, which is 729. So in order to find this, we copy the 1/4 and then the first term times the 1 minus the common ratio. Now it's pretty clear that it's 1 over 3 to the n, to the number of terms. So we have 1, 2, 3 up to 6 is 6 terms, plus this term here, 7 terms, over 1 minus 1 over 3. So let's just do the math. So 1 over 4 times 1 over 3 to the 7, and then if we multiply by 3, we get 2/3, or 1 over 4 times 3 over 2 times 1 minus 1 over 3 to the 7. So it's 3 over 8 times 3 to the 7 minus 1 over 3 to the 7. So we can do 3 to the 7 minus 1. I'm trying my best to use the calculator as little as possible. So now I just have to put it in the calculator. So I got 1093 over 2916, which we can calculate that with in decimal form. Let's take a look at another one. Evaluate the following geometric series or state that it diverges. So this one, if I write it out, it's going to be 1 because we give k value of 0. If k equals 1, it's 1/4. K equals 2, it's 1/4 to the second. 1 over 4 to the third, and so on. So what we're going to do is let's evaluate, let's find out what S sub n means. So it's 1 plus 1/4 plus 1 to 4 to the second plus dot 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 1/4 to the n. So being a geometric series is 1 times 1 over 4 to the number of terms. Or maybe I should have stopped at 1 over, n plus 1 minus 1 over 1 over 4 minus 1. So we get, can do a little bit of math here, minus 1 over, and then this one is negative 3 over 4, so I can multiply it like here times negative 4 over 3. So limit as n it's approaching infinity of S sub n, it's actually limit as n it's approaching infinity of what I wrote here. So I can put negative 4 over 3 first, and then 1 over 4 to n minus n plus 1 minus 1. Now this quantity, it's approaching 0, right? We saw that this series, it's actually, this sequence, it's approaching 0. Or we can say, well, this is the same as 1 over 4 to n plus 1. So it's like 1 over infinity. So if you have one bread and you split it to millions and millions of people, how much bread you give them? Well, almost 0, right? 4 over 3. So this is what this geometric series equals to. Let's take a look at this one also. So S sub n is going to be 1 minus 9 over 10 plus 9 to the second over 10 to the second minus 9 to the third over 10 to the third. Plus and so on, right? So basically, the common ratio is negative 9 over 10. To get to the next one, we have like that. The first term is 1, so S sub n is going to be 1 times negative 9 over 10 to the number of terms, let's say n plus 1 minus 1 over negative 9 over 10 minus 1. So if we do the math, it's going to be negative 9 over 10 to n plus 1 minus 1, and then everything times. Well, if we compute this, we get negative 19 over 10, so negative 10 over 19. So the limit, as n is approaching infinity, of s sub n is going to equal, well, this quantity, because, oh, I thought I was highlighting, this quantity, because it's less than 1, is going to approach 0. It's actually alternating, but it's going to approach 0. We actually end up with 10 over 19. And let's take a look at another telescopic series. So if we want to find s sub n, we go n equals, or k equals 1. We get square root of 2 minus square root of 1. Plus, this sum means each term. Now, if this is for k equals 1. For k equals 2, we get square root of 2 minus, square root of 3 minus square root of 2. Plus, if k equals 3, we get square root of 4 minus square root of 3. Plus, square root of 5 minus square root of 4. Plus, dot, dot, dot. If for n, it's square root of n plus 1 minus square root of n. And, you know, I actually prefer to write the previous term, so I'm going to try for k equals n minus 1. N minus 1, I'm going to get square root of n minus square root of n minus 1 plus square root of n plus 1 minus square root of n. This is for k equals n. So what happens? Well, the first term cancels to the fourth one. The third term cancels with this one. Now, square root of 4 with this one. Square root of 5 is going to be somewhere here. Square root of n with this one. So the ones that we cancel are the negatives are after that. So basically, this negative is going to cancel with something in front. So this s sub n, it's actually equal to square root of n plus 1 minus 1. This one here. So limit, as n is approaching infinity, of s sub n, its limit, as n is approaching infinity, of square root of n plus 1 minus 1, which is actually equal to infinity. So the series diverges. I hope this helps.